Hello and a good time of day to you. Here's the circuit board from inside another Spectrum I've been sent for repair. Its owner reports that it sometimes works, but that it tends to spontaneously reset itself or crash in mysterious ways. As soon as I opened the case, I suspected some repair work had previously been done to it, because the upper RAM and the support logic for it are mounted in sockets, and that's unusual for an issue 3B. Further, the upper RAM ICs here are 4164s, and so far as I know, they were never fitted at the time of manufacture. Looking at the rear, it's difficult to tell whether or not these RAM ICs have been replaced, but a few of the solder joints do look a bit different, and there's some additional flux residue around some of them, but it certainly looks as if whoever did this work did a good job. As usual, I'm going to go ahead and replace all of the electrolytic capacitors, using the technique I demonstrated in another video. Normally I just discard these, but in this case I'll retain this one here, C27, for some testing, as it's possible that can cause unexpected reset problems in a Spectrum. This capacitor is responsible for resetting the CPU at power on, and if it's faulty, particularly if it's become very leaky, then it could cause the Spectrum to reset at other times. But before I do anything, I'll very quickly go through the standard set of initial tests that I always do using this multimeter. So I'll connect this common terminal to the heatsink, check there's continuity between there and the 0-volt connection at the lower RAM. There is. Now I want to measure the resistance between that and the 5-volt supply. That seems normal. The minus 5-volt supply. That's about as it should be too. And the 12-volt supply. Switch to a higher range. It's normally 2.7, 2.8 kilo ohms. Yes, that's correct. Don't think there's a problem there. Switch to the Diode Test mode and make a quick check of transistors TR4 and TR5. Start with TR4, which is an NPN transistor. Suggests there's nothing wrong with that one. Now for TR5, which is a PNP. That reading's normal for when the transistor is installed in the Spectrum. There should be no conduction this way. Good. So I don't think there can be much seriously wrong with this Spectrum. I've noticed one other thing that could be a cause of a problem, and that's down here. I'll remove the heatsink to get a better look. These pads up here are for selection links to determine the type of upper RAM in use, and a green wire has been installed between these two pads here, and that selects Texas Instrument type RAM. However, there should then be a jumper in one of these positions marked 3 or 4, and that determines whether the upper or lower half of the RAM is used. Neither of these positions has a link installed, and that might be the cause of a problem. Here's a section of circuit diagram showing the upper RAM address multiplexers and the arrangement of the connections to the RAM type selection links. In this spectrum, a link is installed here, labelled TI for Texas Instrument RAM, and that means that address line A14 is connected through to input 3A of this multiplexer. And I think that should mean that address line A14 contributes to the row portion of each two-part address presented to the upper RAM. Input 3B should then be held high or low to select which 32K half of the 64K RAM ICs is used. And that's done by installing a jumper either in position 3 here, which connects that input to 0 volts, or in position 4 here, which connects it to 5 volts. But in this spectrum, neither of those are in place, and so input 3B to this multiplexer is left floating. And normally a floating logic input is interpreted as a high, but it's not good practice to do that, and if anything should cause that to now and then be interpreted as a low, then that would change the half of the RAM in use, and that almost certainly would cause the spectrum to crash. I've replaced all the electrolytic capacitors. I've also installed a new power input socket here, which is something I normally do as part of a repair if the original is at all grimy or corroded. I haven't touched the upper RAM type selection links, as I want to see whether leaving one of the inputs to the address multiplexer not connected causes a problem. Even if it proves not to, though, I will install a link in position 3 or 4 before returning this spectrum to its owner. Here's the capacitor that was installed as C27, and I want to perform a couple of tests on it to see whether that could have been the cause of the spontaneous resets that were reported. So first I'll simply measure its capacitance. It's supposed to be a 1 microfarad capacitor. And indeed it seems it still is, so not a problem there. I now want to check measure its leakage current, which should be very small, but if it's not, then that could be causing the reset problem. This capacitor is rated at a maximum voltage of 50 volts, but in the spectrum it's only exposed to 5 volts. So I'm going to test it with power supply set to 15 volts. So we'll only take it a bit beyond what it would have witnessed in use. Make sure I connect this the correct way around. So this lead comes from the power supply. As does this one, which I will connect to the multimeter. So I'm placing the multimeter in series with the capacitor. There we go, set to the milliamp range. It's only a 1 microfarad capacitor, so I don't need to worry too much about the initial surge current that will pass through the meter. So I'll switch the power supply on now. Switch the meter down to its microamp range. That's a very small leakage current. Shouldn't cause a problem in the spectrum at all. Check that current really is the leakage current through this capacitor by breaking the circuit. That is indeed the case. Okay, so I don't think the problem was due to capacitor C27, as this one seems to be healthy. Before I power it on, I'll quickly recheck the resistance measurements that I made at the start to make sure I haven't introduced any power supply faults. So this is the 5 volt supply, minus 5 volts, and 12 volts. The readings are almost exactly the same as they were before, so there's no problem there. I've loosely placed the circuit board back in its case, connected a keyboard, and connected the composite video output to a television. I've got a 9-volt power supply ready, so I'll switch it on and let's see what happens. Good so far. The initialization time suggests that it probably has started as a 48K spectrum. Let's see what value the initialization RAM test found for the highest byte of working RAM. And the value in the byte above that, 23733, should also be 255, which it is. That means it has initialized as a 48K spectrum. So at this point there's nothing obviously wrong, so I'm going to load and run a memory test program and just leave that running for a while to see whether any problems occur. The memory test program ran for quite a while without encountering any problems. It uses a little machine code routine to fill all of the upper RAM with a sequence of randomly generated bytes, and then immediately reads it back to make sure the RAM still contained what had just been written, and then it does it again and again and again, forevermore, until it finds a problem. But we can see here that it stopped because it's found a single instance of a byte not containing the value that it had written to it. I would think that error occurred either because there's a faulty upper RAM IC, or probably more likely because one of the inputs to one of the address multiplexers was left floating, as I pointed out previously. So here, I've replaced the green wire that was in this position previously with this neater wire link to select Texas Instruments type RAM. By the way, because there are 4164 ICs installed here, it doesn't matter whether the spectrum is configured for TI or OCI RAM, but the link needs to be installed in one of those positions. And then I've installed a new link here in the position labelled 4, so that should tie the previously floating input to the address multiplexer to either 0 volts or 5 volts. I'd have to look at the diagram again to remember which. And again, because 4164s are installed, it shouldn't matter whether I've installed this in position 4 or position 3. So now I'm going to run the memory test program again to see whether this has cured the problem. This time the memory test program has stopped after about 12 minutes and again reports a single error. The report indicates errors were found in multiple bits, but not even the same bits as was the case last time. The symptoms aren't those that typically occur when there's a faulty RAM IC, so I'm not too sure what's causing this. It looks rather more like an addressing error. I then ran the test program again without resetting or turning the computer off, and that time it stopped immediately reporting the errors you can see here. And like before, they aren't consistent with any particular upper RAM IC or set of RAM ICs being faulty. So this again looks like an addressing error, and I was starting to think that perhaps one of the upper RAM address multiplexers must be faulty. And then, while sitting idle like this, there were 2 brief pulses of buzzing noise from the computer's internal loudspeaker. That certainly shouldn't happen, and it suggests that something's interfered with the execution of the computer's basic operating environment, or perhaps has corrupted its system area of memory. There are a number of tests I could do now, but what I think I'm going to try is removing all of the upper RAM to see whether the computer works reliably as a 16K model. I could then try an SRAM module in place of the 8 individual ICs that form the upper RAM. I could also try replacing the upper RAM address multiplexers, which will be easy to do because they are fitted in sockets. I've removed all 8 of the upper RAM ICs and set the computer running the memory test program again, testing a region of the lower RAM, which it happily did for a while, but then it stopped with an out of memory error message, as you can see here. That's not something that should happen, and that's not what normally happens when I run this program on a 16K spectrum. And then while it's been sitting here, every so often there's been a brief buzzing noise from the computer's internal loudspeaker. So clearly there's something wrong that has nothing to do with the upper RAM. Something rather strange seems to be going on here. I thoroughly cleaned the PCB and went over the underside of it with a stiff brush to dislodge any debris that may have collected there. I also reseated the ULA in its socket. I then loaded up the test program again and had it running for quite a long time without it reporting any errors. In all previous cases, I had the Spectrum set up as you can see it now, with the keyboard connected and the uppercase half just placed loosely on top of it. However, for that test, I had the uppercase set aside like this, and the test ran for probably 40 minutes or so and reported no errors. I then, while the test was still running, moved the case lid back into position like this, and almost instantly the test stopped and reported several errors. Just had the test running again with the lid in place like this, and it ran for a good long time before stopping and reporting the errors you can see here. Now earlier on, before I started any of these tests, or just ahead of the first one, I did have a problem, and that was that the keyboard stopped working properly once I put the lid back into place. Now that's a problem I've encountered a number of times before, so I wasn't too surprised. And usually it's because the insulation on these modern replacement keyboard membranes, the insulation on the tails here, is rather thin, and where it rubs against the edge of the modulator can here, it can short out the connections. So I placed a piece of adhesive transparent plastic over the front edge here, and that seemed to cure the problem. So I think if the problem really is being triggered only when the lid is in place, then either it's due to some sort of inductive or capacitive coupling between the keyboard and something in here, or maybe these tails are still making contact with something they shouldn't. So I'm going to try placing a piece of adhesive plastic over the exposed parts of these tails to make sure they're electrically insulated from any of the circuitry. I applied a piece of adhesive plastic film to the downward facing side of both of the keyboard membrane tails to make sure they can't come into electrical contact with any of the Spectrum circuitry, but that doesn't seem to have helped. As you can see here, the memory test program came to a halt after about 15 minutes. I can also see something I hadn't noticed before, in fact I don't think had appeared before, and that's there's some corruption of the display in a few places. For example, here and here. And of course that would be consistent with corruption of the contents of the lower RAM. So maybe the problem's due to an intermittent fault with a lower RAM IC, or something else interfering with access to the lower RAM, maybe even a ULA fault. There are a whole load of possibilities. It does look though as if these errant pixels are all appearing in the same bit position of each character. So I'm going to work out which bit that corresponds to, and perhaps it might be worth trying exchanging just the single lower RAM IC that provides that bit. Before switching the soldering iron on again, I thought I'd try a different ULA in this Spectrum. Now it's been running the memory test for a bit over half an hour, and that's the longest run it's had so far without reporting any errors. So sadly it looks rather as if the problem was due to the ULA. I'll leave this test running for a bit longer, and I'll try the suspect ULA in another Spectrum to see whether it exhibits any problems there. I took the ULA from this Spectrum, the one that was apparently causing the problem, and tested it in another one. I let that run the memory test program for about 40 minutes, and no errors were reported. I then put it back into this computer, and after only a few minutes of running this test, it stopped with an error message reporting a couple of faults found. Curiously, in both of those reports, it indicated a problem in bit position 5. And the errant pixels that appeared on the display that I pointed out earlier also were all in bit position 5. So I thought there wouldn't be much to lose by replacing IC11, that's the lower RAM chip that provides bit 5 of all bytes of the lower RAM. So I've done that, put the original ULA back in, and have had it running the memory test for quite a while, but now it's come to a stop again with this rather bizarre message that you can see here. At this particular address, it read the value 4 and had been expecting to find the value 4. So clearly some part of the basic operating environment or the program itself has become corrupt again. So sadly, I think I have to accept the problem is due to this ULA. It just seems a little bit strange that it apparently works perfectly in another spectrum, although I have previously once or twice come across a ULA that seems to work well in some spectrums and not in others. I fitted a different ULA, this time A-6 variety, the same as was originally in this spectrum, rather than the -7 type that I'd experimented with before, but both should work in this computer, and again, it appears this has cured the problem. The memory test program has been running for a few hours now without a single error report. So I'm fairly confident this is now a perfectly functioning 16K spectrum. So I'll refit the upper RAM, and hopefully I'll then have a perfectly functioning 48K spectrum. I refitted the original 4164 upper RAM ICs, and then left it running the RAM test program for an hour or two. That didn't report any errors. I've completed a few rounds of Manic Miner, defeated it at Chaos, and now it's busy battling itself. There are a few more checks I want to carry out, but at this point I'm happy to say that I think this spectrum is fully repaired. Here I fitted the apparently faulty ULA to another spectrum, in this case another issue 3B, and it's been running the memory test program for almost 2 hours now without any errors reported. It also seemed to work perfectly well in an issue 2 spectrum that I tested it with earlier. I'll leave this test program running for a bit longer and try running a few other programs, but it looks as if this ULA generally works perfectly well, but for some reason the combination of it and the other spectrum just didn't work properly. Given the symptom of occasional corruption of the RAM contents, I rather suspect there was a problem with the memory contention handling. However, I suspect it will take quite a long time and be rather an involved job to work out exactly what was going wrong, and frankly I can't really be bothered to do that. While I've not seen exactly this type of fault before, I have previously encountered the occasional ULA that generally seemed to work perfectly, but just in one or two particular spectrums had problems. So I'm going to put it down to being one of those odd things that happens sometimes.